Good afternoon, everyone. I am Aravindhan TV from Lovely Professional University. Today, I'm here to explain about the project which I had made in the internship period from Emetxe. So, a project is microwave oven simulation. We are using Pixim Lab and MP Lab XID for making this project. And let's see about the project. First, we everyone know this internship is basically of for the embedded systems. So what is embedded system? Like we know our mobile phones, our personal computers. Those are the embedded systems. Definitely not, because these are meant to be work for the multiple tasks, the multiple situations. It is made to run multiple general purpose programs. It is called as general purpose devices. It uses general purpose operating systems. Embedded systems are the systems which is designed specifically for the specific purpose, like ADAS for the cars, airbag systems, and the cruise control systems in the cars. It speak about the difference, the radar systems, the communication systems. Those are the part of embedded systems. Embedded systems often a part of a larger system, like either mechanical or an electrical systems. And embedded systems mostly operate with the real-time constraints. So there are two types of real-time constraints: hard real-time and soft real-time. Soft real-time is where the deadline, meeting the deadline is not an important thing. It won't affect the system. But the hard real-time is the thing, the meeting and without meeting an time constraint will lead to a catastrophic failure, like the airbag systems in the car. If it didn't open within the specific time, it could be a big disaster. So next, what we have learned in the internship, it is a 30 days of the internship, which we have 30 to 35 days of the internship, which we have classes, regular classes of 2 hours a day, where we got an intro about the embedded systems, what is an embedded system, how it is contributing in the real world, and how it is developing and how it is improving. And then after that, what are the components of the embedded systems. Then we learned about the PIC16 F877A. It's a microcontroller. It's basically a microcontroller from the PIC family. It is an 8-bit microcontroller. So we learned about the microcontroller, MPLAB XID, how to use MPLAB XID to code the PIC microcontroller and simulate it with the PICSIM lab. So we have gone through the both theoretical aspects as well as the practical knowledge as also. The project is also an added advantage for the practical learning, which students can able to demonstrate what they had demonstrated and apply what they had learned in this internship period. And everyone can ask, why microwave oven? It is literally a real world example which we can be able to use timers, finite state machine FSMs, and input output displays, everything. So the key goals, speaking about the key goals, the main outcomes of the internship is, first we need to master the embedded C. Embedded C is nothing but the extension of C, which has some extra features like bit based operators, bit manipulations, and so on. After that, we'll have learned about the PIC microcontroller, PIC16F77A. So we have learned about the architecture, memory organizations, register architecture, and how the data flows over there, everything, how to read the data sheets, and how to use the memory mapped peripherals and everything. Then for the peripheral interfacing, we had interface with the LCDs, keypads, fans, buzzer for the project. So we had learned how to interface everything alone as well as how to interface everything together with the logic. And then the main thing is that we had an exposure for the real world project development. See, the project development is separated into many things, but the thing is, from the starting scratch, reading the RDD and understanding the requirements of the project and working alongside with it. So we had an exposure to work with the structured project which we haven't structured. We to do like this is the output. So we work with the vision, and then we had implemented a modular programming over there. Instead of making the clumsy main.c code, we had used the header files, .c files for different peripherals, and then we are like including in a main.c file. So after that, what are the requirements for the project? First we will see the functionality requirements. First we need a 16x4 LCD for a feedback. For we need to display everything over there for in the LCD. Next we need a keypad for the input. We are having a matrix. We are having a 4x4 keypad in this simulator board, Big Genius board, but we are using the 3x4. We are not including the RB0, RB1, all those keys. And then we need timers. It's a finite state machine which we are using it for to set a precision time for the cooking durations. Then we are having adjustable temperature setting also. It's only in the convection mode. We'll talk about later. And then we have an integrated fan. The fan is like it is an imitation. It's a simulation for the microwave. The fan is on, the microwave is running. The fan is on, the microwave is not running. Then a buzzer for the alert. It will basically give the alert when the cooking is done with a regular normal microwave. And then speaking about the non-functional requirements, this code is highly modular for maintaining the scalability. Making the clumsy .mainc file, it is very unorganized and unstructured. If there are any bug over there, if there are any error over there, it's hard to find, and it is hard to scale or add any feature or maintain the project. And then it is a very user-friendly interface design, and having a reliable timer implementation, because like timing is very important in microwave. So see about the system architecture, what we have used. First, the main part of the project is PIC16F877A. It's a CPU. It is a main microcontroller which we are going to control all this. And we talk as the thing we talked before. We are using 16x4 LCD. This LCD is for displaying all the values, modes, and the temperature what we are setting over there. And the matrix keyboard is for the inputs. I can take the input from the user to operate the microwave, and we are having a fan that simulates the microwave heating, and buzzer for the completion alerts. And then speaking of the software architecture, as we say that this is a fully modular code. First the speak of development environment. We are using MPLAB X IDE. It is an integrated development environment for PIC microcontrollers released by Microchip, and the compiler we are using for it is XC8. It's converted the C code into a machine executable instructions. Basically a bridge between the high level language and the machine language. And then the last thing is the simulator. We are using a PICSIM lab. It is a platform for testing and debugging the controllers. So having various boards and the microcontroller, now we are using for the PIC. And we will see about the file structure or code structure. First, as we can see, we are having main.c file. In the main.c file, it's having the main program loops, having the system installation and the overall flow control. And then we are having a microwave.c and the microwave.h files. The C stands for the C file and the H stands for the header file. Like it is having the code, microwave logic, mode management, and the state transitions also. And we are having ccld and .c and ccld.h. It is a custom character LCD. Actually, it is a display driver. You can say about it's a driver. .h it's a driver. We're building a driver for the LCDs. Then we are also having a .c file also. Then we're having a matrix keypad.c and matrix keypad.h in this what we're doing, like we are also making a driver for scanning and debouncing the matrix keypad inputs. Basically there are push buttons over there in the matrix keypad. Then we are also having the logic for the fan as a fan C and fan H, and same as the logic functions for the buzzer also, buzzer C and buzzer H. And this is the like systematic development process. This is the process which I had followed to like develop this project. First, I started with the LCD. I had write the code for the LCD, write the header file, made the driver, and then made the code and just making it printing hello in the LCD and hello word in the two lines. Then I had moved to the keypad, and now I had made the keypad driver, and I had interfaced the keypad with the LCD. Just if what are the number I am pressing in the keypad, it will display on the LCD. And after that, I had made the drivers for the buzzers and fans also. And after that, I had made the whole microwave logic, including the three modes: grill, micro, and convection modes, and the timer setting the time over there, implementing the FSM over there. So all those things. Then integration, like I had integrated the main logic with all those drivers, including over there, and made a complete system. After that, I had test the system whether it is working or not, and I had gone through for many debuggings. Actually, comparing to the development, debugging is much harder in embedded systems. And the main key implementations are the mode selection logic. First, we have the state machine which switch between modes: micro, grill, and convection. It is a keypad based input modes. And then time and temperature entry. I had developed routines for numerical input which we are giving via keypads, including like the time validation for time and the convection temperature. And start, pause, stop logic, like managed by the cooking cycle states, allowing users to initiate. Like actually we can able to, once we set the timer, we need to press start to start it, we can pause it, or we can stop it. And then timer countdown algorithm, like once it is like the timer is set up, we need to like count, like we need to like take a second by second countdown, which it will reduce and will become 0. Once it is 0 and every process is stopped and the buzzer is starting to beep. And the fan controller, the fan is like, it is used to simulate the heat dissipation, like it's used to cooking, it's used to like simulate the cooking. When the microwave is on, the fan is on. Because the microwave is off, the fan is off. And the last, the buzzer is used for the finishing things, like once the cooking is finished, the buzzer is on. And then there are multiple screens over there. First is the power on screen, it will display like the power on message over there, and then we will select the mode selection screen. After that, once the mode selection is done, after that we need to make the temperature settings. We need to select the temperature like properly, that is only for the convection mode. After that we need to go for the time, we need to give the time also in minutes and seconds format. And we need to, and then there is screen which enter to the start, pause, stop, which will control the working of the microwave oven. And the fan operation is there, and the buzzer operation is there. Yeah, before going to conclusion, I would like to give the demonstration of the project. As you know, this is the project. First we'll make the demonstration. I'm making it the reset. As we can see, the power on screen is there. So again, so you know the power on screen is over there, powering on microwave oven, and there will be 3 modes over there: micro, grill, and convection mode. In the convection mode, like first we will give the number 1 for the, it will display the power, it's 900 watts. After that we need to give the timer. I'm giving just 0, 0, 1, 10 seconds, and pressing enter hash. It will showing the time is 10 seconds. Start, pause, stop, I start, the fan starts spinning. You can see. And if I press 5, it pause. The project is paused. Then after that, if I press 4 again, it resumes. After 4, you can see the buzzer is there. As you can see, after 10 seconds, the buzzer had been over there. Same like in the grill mode also. The power is of 700 watts. And right now I'm setting 1 minute as a timer. 0100 hash. When I start the project, when I start the things, the fan is started running. It is running means like the food is cooking in the oven. So meanwhile it's running, like we had used this matrix keypad. It's 3x4 matrix keypad. Instead, like we are not using RB3, RB4, RB5 and RFIs, these pins. So the thing is we are only using the numbers over there. Yes, we are approaching to 6, 5, 4, 3, 2, 1. After that, you can see the fan stops and the buzzer starts beeping. Yeah, the buzzer will be for exactly 5 seconds. After that, we are entering in the convection mode. The convection mode's power is 4200 degrees Celsius. Like 1 second, I am resetting it. The conversion mode is 1200 watts, and we need to set the temperature. First, we need to set the temperature. I'm making it like 80 degrees Celsius. No, like I'll make the 5 degrees Celsius. After that, if we need to clear, we can press the star over there. It will clear it. If I need to again give it 080, now it's 80 degrees Celsius. And if I press hash, go to next, I need to give enter the time also 0010. Okay, then 10 seconds at 8 degrees Celsius. When I started this, the fan started running. After that, you can see the buzzer is also over there. So the main things we have used is the buzzer, it's here, and the fan, the keypad and the display. I am using the 16x4 display here. It's HD 44780 displays. Speaking of the code, you can see this is the modular approach. You can see here, this is the modular approach over there. First the thing I have started with the CLCD. This is the header file for the CLCD. This is for the enable, this is for the RS, and this is the data port. We are using D, like the port D as the CLCD mode. We are interfacing this with the 4-bit mode, where we can interface LCD in two modes. One is the 8-bit mode and the 4-bit mode. Here in the 4-bit mode, the data frames from D4, D5 to D8, no, D4 to D7. Yeah, the pins from D4 to D7 will use, and the frequency which we are using is 20 Hz. This is the crystal frequency, and then we are currenting E2 as the reset and the port E2 and port E1 as the enable. And after that these are the 4 lines. This is the line 1, line 2, line line 3 and line 4. This is a command for the lines. Go to the next rows and then yeah, this is the like the code for the CLCD. And then speak about next. After CLCD, we are using the matrix keypad. In the matrix keypad, like we are using the column input for the row, like it's a B. We are using port B as for the column inputs, and the row ports for like we are using the column D, like RD3, RD2, RD1, RD0. Column 1 is RB0, RB1, RB2, and we are defining high as 1 and low as 0 and state as 0, 1 and level as 0. And when everything is released, then we are using 0xff. After this, we are like having the header for buzzer. It contains some function prototypes, and after we are currently the buzzer as RC1. We are using like C1 RC1 for interfacing buzzer, and this is the C code for the buzzer. When it is there, it gives buzzer as 1. When it is not there, 0, and we are having the delay using the for loop. And after that, we are having the main header file for microwave. This is having some function prototypes, which is useful in many things, because first is the power on screen, then is the cooking mode screen over there, and the micro power mode screen is there, grill power mode screen is there, and the convection power mode screen is there. After the set time is there for setting the time over there, and for the enter time is there, and the run timer is the thing which I'll discuss later and the further codes. And we have the set temperature screen for the convection mode and the enter temperature screen for the convection mode. And we have some extra like unsigned integer variable. We had declared some unsigned integer variables. We had declared setStron for using in other files. First we have minutes, seconds, and the temperatures. And microwave is there. Micro.c is the main logic. First, this is the we had included all the header files over there. Sorry. After that, we have the power on screen. Here it will print power on microwave with these twos, the stars in the first and bottom line, and we had used the delays as a 2000, like 2 seconds. And then the cooking mode screen is there. It will like display all 3 cooking modes. After that, the micro power screen is there. Like once we select the micro, it will like give the power, display the power as a 900 watts. Same as for the grill, it will display for 700 watts. And convection, it will display for 1200 watts and with the set temperature also. And then we have the temperature set screen for convection mode. Then we are like calling the function after the 2 seconds delay. We are calling the function enter temperature. We will call this function. Once the function is called, we are having the character key and the position. We are having an array which have all 3 a temperature value, like 3-digit temperature value, and it will call the send temperature screen. It will call the screen. Once it is like called, then we need to enter the temperature as this, like this. After that, then it will like assign all the it will read the keypad matrix. It will read the keypad matrix and it will set the like temperature. Same as the set time screen is there. Same as the enter time screen is there. It will use the array. It's like having the length of 4, and then also it will like read the having the while loop one. It will read the value from the display. Once the key hash is fine, then it will break the thing and will go to the run timer. Run timer is the main function over there because it will run all the timers. Once the clear screen is completely, like we need to clear the screen. After that, we need to print the time over there, and it will like start the start, pause, flag is there. It will start the timer. It is having the main FSM logic. You have tick plus plus. We are increasing the timer. First we have start flag is 1 and the pause flag is 0. Then we are like increasing the timer. After that is having all the seconds, minutes, and we are having minutes minus minus and seconds minus minus. After 59 seconds, minutes need to be get minus, means we are decrementing the values. And after the delay of 50 milliseconds, we are like making the fan off and the buzzer is beep for the 5 seconds. I hope like you got an overview about the project which I had made in the internship. So this is the project which I had made in the internship microwave, and with this internship I had learned a lot, learned about the embedded systems, how to program it, how to use the big microcontroller with the how to write code for the big microcontroller, how to use MPLAB XID, and how to use the PixSim lab simulator, and how to implement the FSMs, how to implement the real-time systems, temperature monitoring, and all those things in this project. Thank you.